And by agroecological diversification, we mean diversity of crop species, presence of hedgerows and other habitat, and other approaches to supporting functional biodiversity on the farm. And we asked two types of questions, importantly: where farmers fit on a spectrum of management practices, as well as their agreement with different statements that captured attitudes related to these two dependent variables, just to make things interesting and complicated. So these are a few key findings from our survey. We did a regression analysis to look at the different drivers, farm size, certification status, motivations, demographic factors, and consistent with other research, we found that large farms, in terms of economic size, were more likely to offer better jobs. That's good. And small farms, but in terms of acreage, were more likely to offer, or rather to adopt, diversification practices. Organic certification was generally not a significant predictor of any of these variables, but uncertified farms were actually slightly more likely to adopt diversification practices. But remember, these are all organic farms, like organic identifying. And we found no relationship between diversification and job quality. I still don't know where to point this. Motivations reported by the participants were also predictive of the dependent variables. So motivations for social justice were significant predictors of job quality attitudes, and motivations for land stewardship were significant predictors of both diversification practices and attitudes. But importantly, motivations for social justice didn't seem to translate into job quality practice improvements. And the only variables that predicted better job quality were economic variables of net revenue and economic farm size. Oh, sorry. So when we asked survey respondents about what types of institutional support they received for job quality, the most named support was job quality specifically was government-affiliated workplace safety organizations. This is not surprising. But the second most named support in this open-ended question was none. So obviously farmers are feeling like they're not getting the information or support that they need for this aspect of their farming system. And while our regression analysis highlights that organic certification is a poor predictor of diversification, organic organizations, institutions, networks, and organic farms were the most frequently named support. So clearly the organic movement and institutions are still playing a very important role in advancing diversified agriculture. And the second most important support named were just generally other farmers and farmer networks. So I think one of the biggest contributions of this research, and I know I'm pretty much at time here, was operationalizing this concept of job quality in the context of agriculture. So I just wanted to share quickly a few interesting results that we found, which were, I'm okay? Okay, great. Oh, I was reading the time instead of the time that I've taken. Very good. So we found that several aspects of job quality were positively correlated with one another, notably aspects more associated with more formal or regulated workplace regimes, which makes sense, such as these sort of human resource procedure related aspects, like contracts and grievance procedures and hiring procedures. And we also saw, on the flip side, that the more informal workplace practices that we tried to capture were also significantly positively correlated with one another. So some of these benefits, like non-monetary rewards of the job, level of interaction with employees, and valuing the opinions of employees. And we also found a significant negative correlation between wages and these more informal aspects of the job, which suggests that employers are compensating for low wages with other more informal benefits that you would see on like small farms with apprenticeships. And this is consistent with sociological and qualitative literature on job quality. So it was really neat to see that this showed up in our survey. So just a few key implications. Examining these two dependent variables alongside each other really enabled us to see that they kind of stem from distinct drivers, and that certification is not one of these among organic farms. but that the organic movement and organic institutions do play a role, at least with respect to diversification. And our results show that while social justice motivated farmers might translate some of that into some more informal practices captured in the attitude scale, in general, farmers are not receiving enough support even to enact the motivations that they have into concrete practices and improvements in the jobs that they offer. And just as sort of a key takeaway, we can't assume that sustainable farming will be achieved by addressing field management practices alone, and transitions to more diversified farming systems risk causing sustainability trade-offs if farmers aren't supported to address job quality alongside ecological management. And just a few notes on future research. I think that future scholarship can really continue exploring different aspects of farm size and how that mediates outcomes related to social well-being and the experiences of workers alongside ecological health, and really addressing these two together is really important. And much more work can be done to build on and adapt this job quality concept in agriculture. First and foremost, incorporating worker perspectives about what they want to see as part of their ideal job or improvements to their conditions of work would be crucial. And then also just acknowledging the limitation of this approach being specific to this context, but that food workers deserve dignity and good conditions of work all around the world, no matter what. And so there's just so much more room to study these aspects in food systems generally. And finally, I think that the survey-based method has the potential to be applied at a much larger scale and definitely improved upon, but that this could really help us get a sense of the human dimension and that facet of agricultural systems and human well-being. So just quick thank you so much to my wonderful co-authors, Naveen Ramankutty, Claire Kremen, and Hannah Whitman, my lab group, and my funding from SSHRC in Canada. Thank you.
That was great. Some good handling of the technical difficulties.
Oh, I don't know what was happening.
We have time for a few questions. Yes. That's We're up time for questions now.
Thank you. Is it on? Ah, perfect. Hi, thank you. Great presentation. I'd be curious to know if, aside from the job quality, if you could find any impacts on the number of total jobs that would be available in the different systems.
We didn't really look at that. I did try to come up with a really detailed way of measuring the quantity of hours of work, but it was kind of a complicated aspect of the survey. So in the end, no, I don't think we really have a sense of that. But yeah, I tried analyzing things every which way and to look at quality and quantity, and it was just, it felt like the data was poor. That's a good question.
Hi, thank you so much for the presentation. I just had a little bit of a clarification question. So for these organic farms, I was wondering the average size that you were looking at. Maybe if most of them were small or large. And then also of the organic farms, what percentage of these were certified and what percentage of your group were the ones that just identify as organic?
Yeah, so I think 72 were certified and 64, I don't know if that adds up to the right number, but in that range, it was almost half-half, certified and uncertified. And the size, I actually just have that right here. I did this research a few years ago, so I'm just pulling this up. Average size for certified was 40 acres and uncertified 32 acres. So.
Okay, great. Just a tiny extra question. And then for these uncertified, are they selling as organic? Or?
No, that's illegal in the province of BC. So it's more just like they identify as following those practices, but they actually can't use that word to describe what they sell. But they're probably selling direct to consumer. And so they can say things like word of mouth about that. Yeah, and I have like qualitative and participatory research to sort of back that up. Yeah, it's an interesting phenomenon, the uncertified farm.
Great, thanks. Okay, let's thank our speaker again. And yeah, hopefully we've worked out the technical issues. You handled that very well. Awkward, I know. Sorry that happened.
All good.
Okay, so our next speaker is Carole Dalin. I hope I pronounced your last name correctly. Wait, and your first name.
Okay, hello everyone. My name is Kirara. I'm a PhD student from London Economics Group at the University of Bonn in Germany. Today, I'm going to talk about public land use policies have improved biodiversity on the world's grassland. The title is a bit different from the one in agenda. Sorry about that. But anyway, so as you might know, the grassland covers around 40% of the Earth's surface and providing different important services such as unique essential habitat for various species as well as animal-based protein for human consumption through livestock. However, grassland degradation caused by management intensification is a serious global problem. As a consequence, we are observing biodiversity loss on the world's grassland. To improve the sustainability of land management, many countries around the world have implemented agri-environmental policies. Those include grazing stocking rate or period restriction, or fertilizer use regulation, or mowing time restriction. However, grassland has been less studied compared to other land cover types like forest or cropland. Therefore, the empirical evidence of those policies on grassland is currently lacking. So, the research question in your paper is, first, how does agri-environmental policy improve biodiversity on the world's grassland? As a side effect, how is protein production changed in response to policy implementation? And lastly, what kind of country conditions make those policies more effective? So the data we used to capture biodiversity on the world's grassland, we constructed bird species richness based on bird observational point data from eBird, which is one of the largest biodiversity citizen science projects. Using observational point data, we counted how many different species observed for 1 year in each 1 square kilometer grid cell of grassland for both all species as well as only threatened species on the red list. Birds are a good indicator for biodiversity because they are highly mobile and tend to concentrate in healthier grassland with diverse and abundant food sources. So this can capture not only the quality of plant but also the diversity of other organisms like insects. On the other hand, we also constructed potential protein production indicator. First, we capture the amount of feed produced in each 1 square kilometer grid cell of grassland using net primary productivity. And we multiply this by feed efficiency rate, that is the ratio between produced protein and consumed carbon as a livestock feed in each location. So this protein indicator implies the amount of protein produced if the available biomass could be used as a livestock feed. In the end, to conduct country-level econometrics analysis, we aggregate those grid cell level data into country level by taking average of all the grid cell level values. So, as for policy side, we leveraged newly created policy database which include around 6,000 agri-environmental policy from roughly 200 countries implemented between 1960 to 2022. So in our study, we extracted national or EU level land use policies from the database, and we confirmed that all the land use policies here is registration or regulation scheme. As a policy measurement, we constructed policy intensity index. That is the cumulative number of policies implemented from 1960 to each year from 2001 to 2018, weighted by governance ability of each country. Since countries implement new policy to improve the past policy, we assume that this cumulative number of policy capture a trend of overall countries' policy efforts. So this is our policy measurement. The empirical strategy, we conducted country-level difference in difference analysis. The main assumption here is that environment and socioeconomic conditions between country and its neighboring countries are relatively similar. So if we find any different trend in grassland condition over time between them, this is likely to be driven by country-level events such as policy changes. We confirm this assumption by conducting placebo tests. And based on this assumption, we relate policy status difference between country pair to grassland condition changes over time for each country. Our study time is from 2001 to 2018, while controlling for country-specific characteristics and common time trends. So this is specification, but I will skip the details now, and let's move on to the result. First, for biodiversity. Okay, so from column 1 to column 4, we changed a set of controls, but the results are quite consistent. We find a positive impact on positive impact of policy on biodiversity. Specifically, we find each policy leads to, on average, 1.3 more bird species richness, as well as 0.06 more threatened bird species richness. On the other hand, we find negative policy impact on protein production. So policy reduced protein production by 2.4%. That is around 2,000 tons of protein, which is equivalent to around 110,000 people's annual consumption of protein. To summarize, we find that at the global scale, agri-environmental land use policies improved bird species richness, not only common bird species, but also the threatened species, while reduced grass production and thereby food and protein supplies. So far, I was talking about global average policy impact. So now we look at the heterogeneous policy impact on biodiversity among countries with different national institutional quality measured by governance ability or human development index, as well as different national budget levels that is measured by environmental expenditure or GDP of each country. So using these 4 variables, we divided country into 3 groups. That is lower, middle, higher level of each country characteristics, and we compare policy impact across groups. So that this is a result. For governance ability and human development index, we find a clear positive trend. That is, country with better institutional quality shows larger policy impact on biodiversity. On the other hand, for environmental expenditure and GDP, the differences in policy impact between middle and higher level groups are relatively smaller compared to the first 2 results. So we conclude that for national budget, there is kind of a threshold above which policy becomes effective. So we also conducted another econometrics analysis that is so-called staggered DID as a robustness check, and we found consistent results. Furthermore, we investigate the mechanism underlying the impact of policy on grassland condition. We conducted grid set level difference in discontinuity analysis for management intensity changes. So by focusing on the area close to the national border, we find that the policy decreases management intensity on managed grassland, which is measured by grazing stocking rate, biomass production, and intervention frequency. So conclusion. Okay, so summarize the result. We find policy trade-off at the global scale. Policy improves bird species richness but reduces protein production, and we also find a heterogeneous policy impact among countries' characteristics. And better institutional quality makes policies more effective. And as an underlying mechanism, we find that policies successfully regulate management intensity. I will talk about some limitation. So this global analysis successfully captured the global trend, but we cannot look at the details of each policy one by one. As a future work, it would be great if we can combine a global study like this one with a more detailed case study to propose more specific policy recommendations. The second limitation is that now we are looking at only grassland, one land cover type grassland, and looking at the changes in management intensification. But of course, land cover change is another factor affecting biodiversity. So we actually already studied this second paper, the impact of policy on land conversion and implication for biodiversity as well as carbon emission. So I'm more than happy to discuss about this also after the presentation. lastly, policy recommendation based on our findings. To impede further biodiversity loss on grassland, country can regulate land management intensity by implementing public policy without specifically designing a policy to target any particular species. And also, when a country newly implements land use regulation, economic development is crucial for successful policy implementation, but also to enhance the effectiveness of this policy, it is vital to support the improvement of national institutional qualities. That's it. Thank you for your attention.
Well, thanks. That was great. Sorry, it feels very loud. Are there any questions? Okay.
Thank you. Yeah, it is loud. Sorry, I missed the beginning of the talks because I was in another session running between. So maybe you said it, but the first finding here says you have more species richness but less protein production. I assume it's associated with reduced livestock. Did you also look at in the country whether the protein supply was, how does it compare to the needs or to the requirements for dietary guidelines? Is it still above or not, basically?
So in this thank you for your questions. In this analysis, we only find global average policy impact. So we didn't look at country level analysis. But yeah, of course, as next step, we can look at, like, depending on the demand of protein, how the country is performing policy. So that's really important point. Thanks about that.
Actually, I'd like to ask a question.
Yeah.
To follow up on that, do you think that there could be a way to design these agro-environmental policies so that you could get the benefits to biodiversity without the adverse impacts on protein production?
Mm-hmm. So yes, that's our biggest goal. So on global average, there is this trade-off, right? But depending on the country condition, this trade-off or cost and benefit, if I call like that, is different. So yeah, our biggest goal is to identify the country condition which improve biodiversity without the decrease protein production as best as possible. We haven't done the analysis, but that's the goal. Mm-hmm.
Okay.
Yeah.
Great. Thanks. I think we should move on to the next talk.
This one. Good morning. My name is Carla Vergara. From the Freie Universität in Berlin, Germany. And today I'm going to present a published paper in this year that is a collaborative study between different researchers from different institutions in Germany and Czech Republic. Okay. You will ask why grasslands and why in Germany. As you can see in the map, grassland systems in Europe are facing divergent systems, like sometimes they are facing marginalization, specialization, conversion to cropland, and even abandonment. And as already Kirara said, this represents many risks in terms of environmental and social problems. For example, carbon sequestration, protection against soil, recreation activities, and so on. Okay, so in Europe there is this common agricultural policy which tries to support sustainable management in agricultural systems, but it's really not having sufficient efforts. Their efforts are not sufficient because the grasslands are declining in Europe and they are also experiencing a lot of management intensity. Germany is a good example of this, and you can see in the graph. Between 1990s and 2023, they have lost almost 1 million hectares of grasslands. So we thought maybe we can help somehow to improve the policy, thinking about archetypes or what we can say identifying patterns in farms. So maybe the policies could tackle better in groups the farms and somehow improve the policies. So we have two main questions. One, of course, if there is archetype patterns that we can identify in grasslands in Germany specifically, and if we identify these patterns, how they relate to the common agricultural policy. Okay. I will not explain in deep the materials and methods, but it is important to say that we use the Farm Acquaintancy Data Network, which is very good in terms of they have information about incentives, also about the business activities that the farms have in Europe, and they also are very related to policies in terms of subsidies and paid labors, many variables that are important for this relationship. And then we have to select indicators because this data has almost 300 variables. So we have to somehow first select the years that are related to core policies on the CAP. So we use these 4 years, and then we do a kind of pre-selection based on which variables are related to grassland systems to reduce and to have a very good variability and multidimensional idea of the variables. We apply a principal component analysis, and that's how we end up with these 16 variables that can be grouped in five groups, as you see. Okay, so once we have our variables, we decide how to apply the archetype analysis. In this case, we use clusters through self-organized maps, which is a technique that is based on neural network analysis of algorithms. And that's how we got to our clusters, and then we use our expert knowledge to interpret the results of these clusters. And finally, we group them into federal states to see the regional distribution of these archetypes over the years, and finally analyze these changes in terms of the political decisions. So we got these 9 clusters of archetypes, which have the name based on the main variables that form part of the whole cluster. What is interesting is like between the 9 archetypes that we find, 4 we can call stable archetypes, which means we can see them through the years, and they are very quite related to the policies. To give an example, because it doesn't work. Perfect. So this is how we got our clusters. In the y-axis, you can see the 16 variables, and here we represent the national average in Germany. So, for example, if we are talking about the archetype of small ruminant farms, this means that goats, sheep, and ewes are predominant in this kind of cluster, and etc. So we have named these clusters based on the main components or main combination of variables. So this is an example for 1992. Which is interesting is like, for example, we find only one kind of cluster for this year, and then we didn't see it through the times of analysis. I don't have enough time, I think, to explain each of year, but maybe with this graph I can explain what we found in terms of archetypes and policies. So as I said before, we only find this medium mixed farm, which is a very interesting type of archetype because it is related to crop production and livestock units, but not really related to cows or dairies. Somehow this archetype doesn't appear anymore, but we had the emergence of a new cluster called large subsidized mixed farm, which is quite related to the policies between 1992 and 2003 in the CAP, because there were a lot of subsidies, specifically for grains and also for livestock, that make the farms go to a mixed type of farm integrated system, and that is why we see that this kind of archetype is permanent till 2019. 2013 is a very good sample of many policies because this is the last year where we see this crop farm and cultivated land, which disappears in the next years. And this is mainly because there can be three options of why this happened. One is like maybe there was not enough people to work in the small farms anymore, so there was no successors for the activity, and also because the subsidies were not giving incentives to this kind of farm. But it is clear that there are other types. Yes, it is clear that there are other types of subsidies that the policies were improving through direct payments and subsidies, where makes these two new clusters to emerge and persist in 2019. This medium crop farm and the mixed farm, and also this one doesn't appear again in 2019, which is also a reflection of two situations. One is like incentives were more prominent to these mixed integrated farms, large mixed integrated farms and specialized farms, and at the same time that there was a crisis in 2015, the milk crisis. So some type of farms also disappeared because they were already in debt, and when the crisis came they disappeared, and only small dairy farms subsist, but they have a process of internal change. So in the end, most of the farms tend to go to a large specialized type of farm. Yes, okay. So to have a better idea, we can see this regional distribution of these archetypes. It looks a little bit weird in 1992, and this is because these Eastern Federal States were part of the Democratic Republic of Germany, so we didn't have data for these years. But still, we were able to identify 6 types of farms or archetypes for the Western Federal States, where we can see that small dairy farms are predominant. And this changed for 2003, where the Eastern Federal States have the more viability in terms of archetypes, and that is where these large subsidized mixed farms appear, and they persist through the years of analysis. Well, in 2013, what we have is the most variability, or the more diversity of types of farm, and this talks about also the resilience of farms, or how they can cope with different types of situations and policies. While in 2019, this completely changed. There are less types of archetypes, so it means like the policies didn't help to preserve the diversity of farms in Western and Eastern states. Okay, so we have this is a discussion, the conclusion part of the paper, but we have 2 takeaways from it. First, like we believe this is a first of its kind methodological approach because we combine dynamic archetype analysis and the implications in policy. This approach can be also be applicable to other regions for grasslands, and it can be improved with sustainable indicators. But it can also be can help to refine policy in terms of we can use a finer spatial resolution, for example, municipalities, or we can also analyze country-specific policies instead of in this case, the common agricultural policy. What we found in terms of how to tailor policies better in terms of the common agricultural policy is, okay, the policy cannot go farm by farm and help each farm or each type of farm, but in this way, having the archetypes, maybe we can help to tackle these premium payments based on this group of farms. And also, we need better regional strategies that promote resilience to weather or market shifts, like for example the case of the crisis, milk crisis of 2015. And I think that's it. Okay, yes. Another important thing that we found, for example, is dairy farms is an example of a type of farm that has high natural value in terms of grasslands, and these kind of farms are getting lost through time in the analysis. So we think that also the policies have to tailor this kind of incentives and subsidies for this type of farms, because it's a way to preserve high natural value grasslands. Thank you.
Thanks for that. That was really interesting. Are there questions? Because if not, I have some. Okay. Well, I'll ask mine anyway, hopefully. But
thanks very much. That was really, really interesting. I was wondering whether you had done or were thinking of doing any kind of ground truthing with archetypes. So one of the things I often find is when you talk to farmers, they hate to classify their farm in any particular way. So whether that's part of your plans or if it's something you've done.
No, it's not part of the plans. It would be great if we can do it this way. But no, it is a study that is already published. We finished, and there is no plans to continue in this case. Mm-hmm.
Thanks for the very interesting presentation. I was just wondering how much you've characterised a narrative around each of those archetypes, because I was just looking at your conclusion on what you've termed dairy farms and the danger of misinterpretation, because some dairy farms are very intensive, lots of fertiliser use, very bad for biodiversity and water quality, whereas clearly you're talking about different types, I assume, of quite extensive dairy farms. Mm-hmm. And I'm just wondering again about the messaging, about how you describe those archetypes and then the implications for other parts of the environment.
Yeah, in this case of farms, we check that how they work in the field somehow through the variables. So we check that where they are located somehow, but yeah, there are specific farms and there are family farms, there are small farms. It's not like big or extensive farms, and they use a more ecological approach in this case. Yeah, these specific farms. Yes, thank you for the note.
okay, I think we should move on. Okay, well, maybe we should wrap it up, I think, and then you can have a little bit more time before lunch and time to ask sort of individual, maybe inside baseball questions like I have some for the speakers. So let's thank our speakers again. And thank you all for coming to this session.